Hello and welcome to STEM with Mr. N, where I perform different demonstrations and explain the science behind what we're seeing. This week, I'm going to show you some science magic tricks with physics as I explore Newton's 3 laws of motion. Let's check it out. British scientist Sir Isaac Newton came up with 3 important rules about how things move and first published these in the famous Principia Mathematica in 1687. These 3 laws are super important in science and engineering and even help people design cars, aeroplanes and space stations. Today, I'm going to show you 3 science magic tricks, one for each of Newton's 3 laws of motion. But first, what are these 3 laws? First law. The law of inertia. Things don't move unless something makes them move, and moving things don't stop unless something makes them stop. If something is still, it stays still until a force moves it. If something is moving, it keeps moving the same way unless a force, like a push, pull, or friction, stops it. Second law, force equals mass times acceleration. The bigger the push, the faster something moves, but heavier things need a stronger push. More force makes things move faster. Heavier objects are harder to move. For example, it's easier to push an empty box than one filled with books. The heavier it is, the more force you need. Third law, action and reaction. Every action has an equal and opposite reaction. When you push on something, it pushes back with the same force in the opposite direction. For example, when a rocket pushes down on the ground with its engines, the ground pushes back, so the rocket lifts off. Let's explore Newton's first law, the law of inertia. For this experiment, you will need a glass of water, a plastic plate, a toilet roll tube, a raw egg, and a surface you don't mind getting wet or can be easily cleaned if things go wrong. I'm going to put my plastic plate on top of my glass of water, and then I'm going to sit my toilet roll tube in the center of the plate. Next, I'm going to place my raw egg sideways on top of the toilet roll tube. Now for the fun part. I'm going to quickly hit the plastic plate out of the way and watch what happens. You'll see that the plate and the tube go flying away, but the egg stays still for a moment. Then, since nothing is holding it up anymore, gravity pulls the egg straight down into the glass. That's because, as described in Newton's first law, an object at rest stays at rest until a force moves it. Next, let's explore Newton's second law, the law of force. For this experiment, you will need 2 funnels of the same size and a gradually sloped ramp that gets wider apart as it moves upwards. You can find cheap sets of these ready for you to piece together to do this experiment, like the one I purchased on eBay. First, I'm going to attach the 2 large ends of my funnel together using a sticky pad. Then I'm going to piece together my ramp, joining my 2 wider ends together and my 2 narrower ends together. To demonstrate this is a sloping ramp, I'm going to place this round pencil at the top and you'll see that it rolls down the ramp. Now for the science magic. I'm going to place my joined funnels at the bottom of the ramp and watch what happens. You'll see that the shape formed by my 2 funnels appears to be rolling uphill, despite what we've learned about things moving downwards due to the force of gravity. Even though it looks like it's rolling uphill, the edges of the ramp are getting further apart, so the roller's centre of mass is actually still going down, even if the ends look like they're going up. The roller moves because forces are acting on it, mainly gravity pulling it down. Its mass and the way it's shaped affect how it accelerates. The roller follows the easiest path down, even if it looks like it's going up. That's the physics trick. Newton's second law helps us see that it's just following gravity in a sneaky way because of its shape, mass, and the force of gravity. Finally, I'm going to explore Newton's third law, action and reaction. This experiment should be done by an adult or with adult supervision. For this experiment, you will need a sharp knife, a chopping board, a raw potato, and a hammer. First, I'm going to put the potato onto the chopping board, and then I'm going to stab the knife into the top of the potato. Then I'm going to start striking the top of the handle of the knife firmly with the hammer. You'll notice that the potato appears to be climbing up the knife as I strike the handle with the hammer. But what is actually happening in this experiment? Newton's third law says that for every action, there is an equal and opposite reaction. When I hit the knife with a hammer, that's the action which pushes the knife into the potato. The potato also pushes back against the knife with an equal force, which is the reaction. Because the force from the hammer is strong and the knife is sharp, the knife still moves downward, cutting through the potato. But all along, the potato is pushing back, just not enough to stop the cut. Every push has a pushback, even when it doesn't look like it. This experiment is a fun way to see how force travels through objects and how opposite reactions are always happening. Well, that's all for this week. I hope you enjoyed it. If you did, please hit the like and subscribe buttons to stay up to date on all future content. As always, I would like to take this opportunity to answer any science questions you have about any science topics at all. So feel free to email me at stemwithmrn@outlook.com and I'll get back to you with answers to your questions. You can subscribe to the channel by pushing the button here, and I've added links here to the other STEM demo and explanation videos I do, here to my series of STEM career interviews, and here to my brand new series of science fiction to science fact. This has been STEM with Mr. N, exploring Newton's 3 laws of motion.